Welcome to the final exam, question number 21, and it gives us a steel bar 2 inches in diameter, so diameter equals 2 inches, and 20 foot long, that's an L, L equals 20 foot, so let's just go ahead and convert that to inches. 12 inches per foot equals what? 240? Let's use the calculator. 240 inches. Alright. Then it says resist a tensile load of, and we know P equals, typically as how I denote tensile or compression loads, of 50,000 pounds. Alright. Says how much is elongate. Assume E equals 29 million, which is a very, very good assumption. I've never not assumed that E equals 29 million for PSI, that is, for steel. Alright, that's a good assumption to make. Let's do it in pink. Why not? Alright, and when you see something deflecting, so we have a tensile load, so it's going to be looking like this. P. And you have, or hopefully just right off the top of your head, it says how much does it elongate. Hopefully the equation that comes to mind is delta equals PL over AE. And that's going to be the change. This P is your P load, is your tensile load or compression load, I guess. L is your length, your original length. A is your area of your beam or bar or whatever you got. Then E, as we said, is 29 million. And that's kind of your stiffness of your beam. How easily would it stress? It's E equals stress over strain. It's Young's modulus. Alright. So let's just go ahead and start plugging and chugging. We do have P. We know that. P equals 50,000 pounds. We know L, 240. We changed to inches because this is in PSI, so inches. A, we want in inches, but we don't have. And E, we already have. So the only thing we don't have is A. So let's figure out what A is. Let's change colors. Alright, A is the area of your beam, or your bar, let's call it. I don't even remember what it is. It's a 2-inch diameter, so we know that. The diameter of something, of a circle, or the area of a circle, I said diameter, is pi r squared, is what I always remember, or engineering-wise, I have since memorized this, pi d squared over 4. And you can derive that from this equation. Just plug d in there, or plug a number for r. Let's say 30, and say it's 30 inches, you know, say pi times, let's go ahead and do that. So you can pi times r, which was 15 squared, that's pi r squared, equals 706.85, then pi times d, which says 30 squared, divided by 4, it should be equal to the same, 706, yes. And that's another way you can justify this equation right now if you haven't memorized it, which I didn't at the beginning, but now I have memorized it because you deal with diameter much more than you deal with radius. Alright, enough with that. I've explained that a few times in a few videos, so hopefully you trust me by now. So this is what? 4 divided by 4, it's actually going to equal pi. 2 squared equals 4 divided by 4 equals 1. Pi divided by 1 is pi. Alright, so that's pi. Sorry, it's probably not the most pretty pi in the world, but it'll do. Okay, so let's go ahead and solve. We have P of 53 pounds, 50,000 pounds, times L, which is 240 inches. And we have area is pi, and that's going to be inches squared. I should have put that over here. Pi inches squared. And you go ahead and write 3.14 or take that out. I, for simplicity, am not right now. But I typically don't like carrying variables through, which I say variable, but that's pi's not a variable. So scratch that. Usually I just put in 3.14. But anyways, 50,000 times 240 divided by pi divided by 29 million. 1, 2, 3, 4, 5, 6 zeros, and you get 0.13. Let's round it to 2 inches. And then let's look at the answer. This should be our answer. And that equals delta. Little case delta. Alright, and let's see if that's one of our answers. And it is 0.132, rounded to what I decided to round it to. Which, yeah, could be debatable what you round it to. But anyways, they have the same answer, so we're good. 0.132, which is B. B is your answer for number 21. Alright, I will see you on question number 22.